Okay, there's a whole bunch of different ways to simplify this algebraic expression and to make all the exponents positive. That occurs on this row right here. But before we focus on that row, let's just look at what's happening. First of all, up here, this is a definition of a negative exponent. X to the minus a can be written as 1 over x to the a power. That's just the definition of a negative exponent. If you have something like a quotient of 2 powers with the same base, you have a choice of writing it x to the a minus b or 1 over x to the b minus a. So, for example, this expression right here, let me go to red. If you want to make the exponents positive, you can say, well, I've got a positive exponent down here, so I've got to move the x to the minus 7 to the denominator. You're using this version of that property. 1 over 12 minus a negative 7, which is 1 over x to the 19th. The exponent's positive. If you have x to the minus 15 over x to the minus 25, since the absolute value of negative 25 is bigger than the negative 15, you want to get this power up here. And you can think of it this way, x to the minus 15 minus a negative 25. That's this property right here. And negative 15 plus 25 is 10. Another way to visualize it, which is the way I like to do it, if I want to get this power to the other side of the fraction, I move it, but change the sign of the exponent. That's just what you visualize. Of course, that just leaves a 1 in the numerator. And then if you visualize it like this, negative 3 plus 7 is y to the 4th. Multiplying powers with the same base, you add the exponents. Okay, what's really happening is you're doing 1 over y to the minus 3 minus a negative 7. Same thing, you get 1 over y to the 4th. Okay, when you have a complicated looking expression like this, there's several different ways to attack it. Probably the easiest thing to do is to use the property of exponents where you have a series of multiplied powers inside the parentheses raised to a power. It's called power of a power. We take this exponent and multiply it times every exponent inside the parentheses. So 3 squared becomes 3 to the minus 6. Y to the 4th, x to the 4th becomes x to the minus 12. And we get y to the minus 12. Same thing down here. Multiply this negative 5 times every exponent inside the parentheses. 3 to the minus 15, x to the 25, y to the minus 25. Now you've got a series of fractions that you can look at. How do you make the exponent positive on the base of 3? Well, the negative 15 has a bigger absolute value than negative 6, so picture moving the 3 to the minus 15 to the numerator and changing the sign of the exponent. It's really 3 to the minus 6 minus a negative 15. For x to the minus 12 over x to the 25th, we got to get the x to the minus 12 to the denominator. So move it to the other part of the fraction and change its sign. And finally, for y to the minus 25, y to the minus 12 over y to the minus 25, we got to get the y to the minus 25 to the numerator. So move it and change its sign. And now you can mentally just add the exponents. Negative 6 plus 15 is 3 to the 9th. Y to the 13th over x to the 27th. And if you actually want to figure out what 3 to the 9th is, it's 19,683. So there's your answer right there with all the exponents positive. Okay, now that's a pretty quick covering of how to deal with negative exponents and all the properties, but hopefully that gives you some idea how to proceed. If you have any questions, post a comment.